What if the very fabric of our universe, the stars themselves, change much faster than we ever imagined? Astronomers have now achieved what once seemed impossible. They've captured, in remarkable detail, a century-long transformation of a dying star. But here's where it gets controversial. The rate of this star's evolution is defying everything we thought we knew about stellar life cycles. Let's dive into the story that's setting the astronomical community abuzz. The spotlight is on the planetary nebula known as IC418, or the Spirograph Nebula, beautifully situated roughly 4,000 light-years from our own planet. To the telescopic eye, it resembles a ghostly, swirling shroud, fitting for a star nearing the end of its journey. IC418 wasn't always so mysterious. Billions of years ago, it was a rather ordinary star, not so different from our sun. Over eons, it burned through every last bit of its hydrogen fuel. As it started to run on empty, the star bloated into a... Now, on the verge of its cosmic finale, it's shedding its outer layers. Rings of gas and dust, expelled by the star, now cocoon its exposed blazing core. This central core heats up at a breakneck pace, releasing fierce radiation that electrifies the nebula's gases, causing them to glow with spectacular, spiraling patterns. And here's something to ponder. Our own sun is destined for a very similar fate millions of years in the future. But what truly sets this study apart is its unprecedented look across time. Starting in 1893, astronomers began recording regular observations of IC418, using over 130 years worth of data, from the careful, manual measurements of 19th century astronomers to the crisp, digital captures of state-of-the-art telescopes. A team of scientists set out to track the evolution of this remarkable star. After painstakingly verifying and combining this data and comparing it to stellar evolution models, they uncovered striking results. The nebula's distinctive green glow, caused by excited oxygen atoms, has increased in strength by about 2.5 times since it was first studied in the Victorian era. That's no minor detail. The finding directly points to a staggering rise in the central star's temperature, nearly 3,000 degrees hotter since 1893, or about 1,000 degrees Celsius every 4 decades. For perspective, our sun needed 10 million years to experience a similar temperature jump during its formation. IC418 is doing it in just a sliver of that timescale. And this is the part most people miss. Even though IC418 is heating up faster than any other dying star on record, it's still lagging behind what our most accepted models predicted. This raises an eyebrow at what we think we know about the mathematics and physics governing stellar death. Could it be that our understanding of which stars produce vital carbon, the building block of life, needs to be rewritten? Does the night sky shift in more dynamic ways than we believe, right before our eyes and within a single human lifetime? Talk about a paradigm shift. Other recent discoveries, such as the mesmerizing swirls of dying stars captured by the James Webb Space Telescope, are starting to paint a fuller and perhaps more complex picture of stellar transformations. Now here's a question for the curious. Do you think the models for stellar evolution need a major update? Or do these findings just represent an intriguing outlier? Should we trust what we observe, or wait for more evidence to rewrite the textbooks? Share your take below, especially if you have a bold or controversial angle. This debate is just getting started.